down 33. First thing I notice, actually let's pay points. Raise your hand and tell me what's the first thing I notice. Hands, come on. Think with me, it's way better than watching. What is the first thing I notice as I look at this problem? Pay you if you can think as I think. Brecken.
Two functions being multiplied, not functions, but two.
Yeah, function is the word. No, it is the word. I definitely see two functions multiplying. How many saw that? 2 points. I see something else. Oh. Multiplying constant. So I like to get that out of the way. How many saw that? 2 points. Okay, as I look at the two functions that are being multiplied, I need to identify that they are of a specific form. So here are the two functions being multiplied. We get the dx. Someone on the test yesterday forgot that last point. The first function, e to the 4x, that is of the form e to the something. So u is always the something, just like the movie. U is something. Okay? U is something. Okay. U is something special. Okay. But look, you can do the test right now. That choice of u came from this function. What is the derivative of 4x? Say it. 4. 4. That is not the other multiplying function.
So it's not.
So it's not the right pick. So just click that. Hands up if you know the other choice for u. So we can talk in a funny way. What other choice for u would you make? You look at the other multiplying function. You identify that it is of a specific form. The form has to be one of these 5. Something to a number. U is always the something. 1 over the something, e to the something, sine or cosine of something. So hands up. What's the other something? Because u is always something. Brennan. Shoot. Yeah, I close. I like close. Brennan, sorry.
Is it something to number?
So the other function is definitely something to a number. So what's the something, Brennan?
E to the 4x plus 5.
Uh-huh. Because u is always the something. Hands up if you knew that before she said it. 2 points. So this one I'm going to do the derivative. Please note this. If this is dx, this has to be dx. This is dt, this has to be dt. It's got to match up, okay? So this side becomes, I want this derivative. We did one a minute ago. Derivative of e to the something is e to the something multiplied by the derivative of that something. The derivative of 5 would be 0. So this something came from here, so this derivative should be this. Excuse me, did it work?
Yeah.
Yeah. This multiplier is 1. This multiplier is 4, no big deal. So raise your hand, what's the next thing I do? Just follow the process. What is the next step? Hands up, come on. Next step. Oh, good comment actually. Yeah, I could do a lot of different things. I apologize for that. Yeah, the order here doesn't really matter that much. That's probably why you felt confused. Like I can start doing stuff here, I can do stuff here. It really doesn't matter. Like I know that over here I'm going to have to multiply the dx across. That was kind of a bad question, sorry. I know I'm going to move the 4. So that's what I was thinking of doing, but the order here is not important. Come over here, get 8, this becomes, oh, that's this one right there. Let's see. Let's put a u in here. These two functions are being multiplied, so the order doesn't matter, so I put this one on this side. Pause there for question.
What's with the u to the fifth?
So remember, that's the whole point of u substitution, is to start making replacements. You're okay. We said u is the same thing as this. So in place of e to the 4x plus 5, I put u. The other thing I did is I said these two functions are multiplying. So the order doesn't matter. So I put that one first. And then I have e to the 4x, then I have the dx. Do you see it?
Yeah.
Points? Okay, please.
Are you just doing this one step like piece at a time, like you haven't, or are we gonna step?
No, keep talking. You're
Are
doing
we gonna
fine.
use u for the e to the 4x?
I kind of messed you up a little bit because I just started doing things in a whatever order because the order didn't really matter. Like, keep asking, but I'll just back up and see if this helps. So I got to here. I picked my u because u is always the something. I take the derivative. I notice that this is good news because these do match, except for the 1 and the 4, which I don't care. I then remembered that every time I do a u substitution, I always multiply the dx across, and I always move the constant. So I kind of stopped here. Came back over to this side and said, okay, what's the point of all this? The point is to transform the antiderivative that uses x into a very simple antiderivative that will use u. So I've done one change. Right here, this is u. So I made a replacement. So u to the 5th, u to the 5th. I said these two things are multiplying, so the order doesn't matter, so I just swapped it. So now I have e to the 4x dx. Next thing I notice is e to the 4x dx is 1/4 du. So one more line. Does that answer your question, Kate?
Yeah.
Good. 2 points. Other question? Please, Cassie.
It like makes sense, but I'm just confused that on the right side, once you take the derivative and you have du equals that, is that just something that we have to know, is to move the constant over to the other side? That's just something we do?
Yeah, there's a reason for it.
Okay.
But I do have to say that for the purposes of our class, this is a bit of a, it's not the most satisfying lesson because it doesn't have that good feeling of like, I understand the why of it all.
Yeah.
It's more about, okay, I guess I understand the steps.
Yeah.
And the steps make sense because I can see that things are equal. I'm not violating anything.
Yeah.
But it does feel kind of weird.
So once you find the derivative, then you move the dx over to the other side and then make sure the constant is over to the side of du.
Correct.
Okay.
And the reason we're doing that is up here we've already moved the constant as well.
Yeah.
We're just trying to get the constants out of the way.
Okay.
So it's easier to see how things are the same.
Yeah.
And so then we noticed right here, this is this.
Yeah. That's
It-
what you just plug in.
Right, it wouldn't have been the same if the constant stayed there.
Okay.
So I just moved it so I could plug it in.
And will there most likely always be a constant that we have to?
The constant may be 1, so you don't have to move anything.
Okay, but we always take the dx.
You always move the dx. Now, to be fair, I've seen teachers teach this in quite a few different ways. This is just my experience saying, I found this to be the quickest way for students to learn. I can actually solve the problem by not moving the dx. I can solve the problem by not moving the 4. It still works.
Yeah.
I just think this is the easiest way to learn it.
Okay.
Is that okay?
Yeah.
2 points. This 1/4 is a multiplying constant, so I pull it out. question? 8 times 1/4 is 2. Now you have what you want. You started with something very complicated using X. Now you have something really simple using U. So pick up the pink sheet. You're like, oh, power rule for antiderivative. So this becomes 2 u to the 6 divided by 6, which is 3, no, 1/3. So it'd be u to the 6th over 3. Which is going to be u to the 4x plus 5. To the 6th power divided by 3. Please.
So once you get to the step, once you get it down to where you can use the pink sheet, you just did the power rule. And you just plugged in what we needed and then added the C.
Yep. The C is always just my final afterthought of like, oh yeah, by the way, I could have had a number there. Please talking. Please talking. That sounded really good. Please keep talking.
Oh, and the integral goes away because when we use the pink sheet. Okay, then.
Yeah, no, that's perfect. You pick up the pink sheet. That's the moment when the integral symbol and the du disappear.
Okay.
Otherwise, you can't get rid of those because you have not found an antiderivative. Like all this other manipulation, we haven't done anything with antiderivatives. So,
Wait, why could you get rid of the du?
it's this one. It's this idea here again. Like the square root of 16 is 4, and the square root sign disappears just because we've done what the square root said to do. That's how I think of it. When we use the pink sheet's saying, like, think of these as brackets. They're saying find the antiderivative of what's in between. The pink sheet tells you the antiderivative is this.
I just thought for du we would plug in the 4e 4x because that's what we got equals du.
Oh, gotcha. Hold on. I haven't paid you a ticket today, right?
No.
That's a good question. That's really good. No, it's very logical because we're making all these other substitutions, right? This is part of where U substitution is still magical for me. Like I've done this for 13 years, I've talked with other teachers, I've still never had a really good explanation as to some of the intricacies of why it works. It seems to be related to some sort of, and they've proved this somewhere, like I said, if you go on to study very advanced mathematics, you'll study it. I studied engineering, so they don't talk about this stuff. They're just like, oh, it works, who cares? Look, we have an antiderivative. We do all this manipulation until we can use the pink sheet. Once we've used the pink sheet, the du is gone. So we don't have to substitute it back. That's not a very good answer, but that's what happens. Okay, as a hint for the homework, listen, it's not really too hard to see. Oh, you're fine. These are kind of cumbersome. I like to have the flashcards, but I don't have a good way to keep them from just getting in your way. On the homework tonight, the problems that, like at a glance, look like they need U substitution, those are the ones that need U substitution. For example, if you're reading down the page, 12, 13, 14, 18, 19, 21, 22, no, not 22, 21, 24, 27, 33, 34, 35, 36, 37, 38.
Is this all of them?
Yeah, this is the whole thing. The vast majority are like, the vast majority go very fast because they're just using the tools. It worked. 4 minutes till the bell.